The next attribute is decentralized data management. So what is it? Well, in traditional systems, we usually have a single database. This single database stores all the system's data from all the components. Usually, a typical system looks like that. So you can see here the system has many components, but utilizes only one database used by all the components. With microservices, this is not the case. With microservices, each service has its own database. As you can see here, the various components, which with microservices are implemented as services, have their own database, and they are not sharing the same database with the other components. Now, there are some important things to note with this attribute. First, this is the most controversial attribute of microservices. In each and every one of the microservices systems I was involved in, there were a lot of questions and challenges related to this attribute. So much so that it is not always possible. Sometimes you will face situations where implementing separate database for each service is simply not possible or just not making sense. And why that? Because forcing separate database might cause problems such as distributed transactions, data duplication, and more. Let me explain that. We said before that we want to model the service around business capabilities. Now, that usually entails that each such capability has its own data, and this data is not related to other services' data, and therefore we can actually separate the databases. However, this is not always the case. Imagine this. We have an e-commerce system. In this system, we decide to go with microservices, and two of the services are orders management and customers management. The first one is responsible for handling the orders in the system, such as adding orders, canceling orders, etc. And the second one manages the customers, their demographic data, login details, and more. From the looks of it, these two services manage two completely different sets of data, so there shouldn't be a problem to have two separate databases, one for each service. However, as part of the requirements, we need to display for each customer how many orders did he submitted in the last 6 months. Now, to save time, we want to store this number as part of the customer's data and not calculate it from the orders database. So now we have two closely related pieces of data which are stored in two different databases. So when a new order is created, we first need to add the order record to the orders database and then update the number of orders submitted in the customer's database, and these two updates must occur in the same transaction. And updating two databases in a single transaction is always a real pain. It makes us use ugly mechanisms such as distributed transaction and two-phase commit, which are extremely fragile and add a lot of complexity, and we end up with a system which is more complicated than a regular monolith with a single database, and we miss the whole idea of microservices. In addition to all that, we also have data duplication, meaning the same data, albeit in different representation, is duplicated across two databases. We have the number of orders in the orders database and in the customers database. And this is always a bad idea, because if one of the databases goes out of sync, the data will not be consistent. So to summarize, this is not always possible, and you, as an architect, should not insist on having separate databases for each service. This should be decided upon on a case-by-case basis. Now, what is the motivation for this attribute? We talked about why it's not always a good idea, but why would we consider this in the first place? So there are mainly two reasons for that. The first, it enables using the right tool for the right task. Not all databases are equal, and some databases are better equipped for a specific task. For example, relational databases are great for complex queries of structured data, while NoSQL databases are great for storing a large amount of semi-structured data. And in modern systems, you will often deal with both types of tasks. So it's good to have the ability to use the right database for what the specific service actually needs. The second reason is that separating the databases encourages isolation. When the team developing the service knows the service has its own database and there is no access to data stored in other services, the design of the service will become more isolated and less dependent on the data from those services. This way, we will end up with a more modular system and with more autonomous services that can be changed without any effect on other services. So, this was the decentralized data management attribute, and now let's move on to the next attribute.